What's up, guys? We are back for part 2. All right, now that we have a networking layer built, let's come on over to the app framework, the app module. Let's start building out the UI, the front end aspect of this. So one thing I like to do is I like to create a DI package. We're going to throw all of our dependency injection related materials inside of there. In this case, we just need an application module. There's really not a lot that we're going to be injecting. There's 2 things that we're going to be injecting. And so we're going to create this as a module. This used to be an application scope. That's why I still like to call it application module. Instead, it's actually singleton component. So feel free to call this a singleton module if you'd like. I just still have the old way ingrained into me. All right, let's make this an abstract class. We're going to demonstrate 2 different ways that Hilt can do injection. We're going to do binds and provides. This is another way to showcase that you know and understand the differences between the 2. These are very important. Binds is my preferred way, my favorite way, because with binds, you just go ahead and give it one parameter and it goes ahead and takes care of the injection itself. So Hilt, Dagger, it's smarter to know what you're injecting in there. So if you were to change the actual constructor signature so that you added in more parameters that are being injected in, Hilt is smart enough to know how to inject those in. Whereas if you do provides, then you're going to have to match up every single element that you're injecting in on both sides and come back to the provides module and update that as well. But there's sometimes when provides actually makes sense. We're going to make these singletons, as I said earlier. We're going to bind the API service. And for this, all we do, abstract function, bind API service implementation, API service, and API service. And notice this is in red. That's because the app module currently does not depend on the networking module. We need to change this. Android Studio is smart, and it's going to give us a little helper here. So again, you can go ahead and press the option enter if you're on a Mac, add dependency on module on the networking module, and enter, bam. Now we just go ahead and sync. And as you see over here, module, we see that it has actually added in a path to our networking module as well. It's pretty cool. Makes your life super simple. Now go ahead and hit option enter again and import it. Voila, we got it. Okay, so we also want to show a provides. And what we do for this, we just go ahead and create a regular class. Now, there's some debate as to if you should put this in a whole nother class, just for simplicity. We're putting it right here. These are low-hanging fruit that allow you to talk about single responsibility. And because there's certain aspects of single responsibility that are actually debated still. So how single responsibility should it be? This class, should it hold all of these modules? Should it not? Should there be one module for the singleton component that handles binds, or should there be one separate one that holds a single component for the provides? And should these live in separate files? Should they live next to each other? That's debatable, especially when you're only dealing with one and one. Well, as these grow, it makes a lot more sense to pull them into another file. And just for clarification purposes, let's call the first one binds and let's call the second one provides. All right, function provides OK HTTP client. And let's go ahead and give it an application context here. So we're going to inject in the context, import it, and OK HTTP client. And this is how we're going to build out the OK HTTP client. So it's going to be built once, and then Hilt is going to go ahead and retain this as a singleton, how to build this. And it is going to go ahead and use this anywhere and anytime that we're referencing OK HTTP. Let's build out a cache. Let's do 10 megabyte cache. Again, this cache section, you can just go ahead and Google, you'll find the exact same code anywhere online. And each provides has to return something. So in this case, it returns an OK HTTP client, and this is what we're going to return with the builder. And we're going to add the cache.build. Perfect. As you see over here in our API service, when we are injecting in the OK HTTP, Hilt is smart enough to know and grab that provides and say, hey, we've built this once. Well, it's going to build the first time and says, hey, we've built this once, and we're going to go ahead and inject it in here as a singleton. And it's going to store a reference to it. You can also use these buttons on the left to drill down to your implementations of Hilt. That's a huge plus. Again, another huge plus using this over something like Coin. All right, one more thing I want to drop in here before I forget is we need to give this an application name. And this is going to be an application file that we have to point to. This is one of the things I usually forget. And then I see the build errors, and then it points me back here. So, oh yeah, that's right. I got to do this. You'll see an error, something about Hilt needing an application entry point, because everything with Hilt has to have an entry point. So in here, we're going to go ahead and create the class, the coding challenges case application. We're going to make it a Hilt Android app. Just simple annotation, takes care of everything that we had to do manually in Dagger. Love Hilt. It's amazing. Makes our job so simple. Now, we can keep this application just this. We don't have to put anything in, but we can also add in the onCreate if we really wanted to. We don't need it in there because we're not going to add anything in there. However, if you wanted to go a little bit further on, maybe show some tools, maybe set up Flipper, maybe set up Timber, this is where you're going to set it up. You can even inject those in here if you wanted to. And okay, I have the wrong version of the cap. Let me change that to 2.44. And the Hilt capped, again, that is the Kotlin annotation processor. It's necessary in order to get Hilt to run properly. Let's go ahead and run. Hello, Android. There we go. Good old friendly Android. This is successful. We can move on to our next step. Let's start building out some of the UI. Let's create a new package here in UI. Let's call it screen. And we're going to create some screens here. We're going to have basically a home screen and a details screen. Let's also build out navigation. That is also very important. We're going to implement the Android Jetpack nav host in here. That's currently the Android standard. There's some downsides to it. I'll discuss that in a later video. In fact, if you want to know how to be able to rip it out and still use all of the benefits of a nav host without having to be bound to Google's implementation of it, stay tuned to a future episode where I'm going to do exactly that. It takes very little work, believe it or not. Rip it out, go ahead and put in your own implementation. They give you all the tools that you need in order to be able to do that, which allows you to have a much more modularized navigation as well if you wanted to, because you can abstract it out how you want to. One of the downsides to using the nav host is actually one of the things that Google is pushing really hard is to basically have a single source of navigation. So you have one nav host where within the nav host, it can navigate to other places, but you don't end up injecting in this navigation component into different places. What feels more common with mobile in general is to be able to have some sort of navigation component you can inject in so that if you click on a button, you can go ahead and get a response back. But they're pushing for the whole higher order stateless components. So that way the lower components aren't aware of certain implementations like navigation, for example. So what they're actually pushing for, it starts with the nav host, which then you can create as a Lambda function for what actually happens on the navigation. You push that in. When you actually push onto the stack, you push a new screen. You go there and you drop in Lambdas for all the actions that screen can do. And you push those down as well as stateless components. You push them down to the very lowest level component, which is going to actually trigger that call. So it'll be pushed all the way down to, say, a button. You click on the button, that button is going to trigger the Lambda that's passed in, and it filters all the way back up, eventually to the nav host where you actually set that up, and it handles the navigation to the next point. So in a future episode, I'll show you how to rip that out and implement your own way if you would like. But for now, let's go ahead and create a coding challenge nav host, which is effectively going to be a wrapper around the nav host component. And like I was saying, we're going to create a home screen. This is going to be a composable, but let's also create a details screen. All right, so come back to main activity real quick. You can see here where this is the default code that we got when we created the app. We have this greeting down here. It's where it was all friendly. We're taking away the friendly hello Android sad day, but we're going to go ahead and create the coding challenge nav host. We're going to drop that in here. And this has to be a composable. Everything within composable has to be composable. And we've set the content as a composable, therefore this has to be composable. Let's pass in a modifier. As a note, most composables should be passing in a modifier. If you're going to be creating one of these, that allows the higher order to be able to set certain aspects of the modifier, which makes it more versatile, universal, reusable. All right, we're going to need a nav host controller. We want to use remember nav controller. It's going to cause lots of errors if you don't. Also, remember is a great talking point in an interview right now. You should know compose at this point. If you're interviewing for an Android position, you also should be be using Kotlin by now. It's been out for several years. You should definitely be using Kotlin. There's a chance you may not have used Compose 2 in depth. You should at least know the basics if you're going to be jumping into a senior level position, though. And remember is a great thing to bring up in an Android interview. All right, let's go ahead and create a nav host. And for this, we're going to want pass in the modifier, pass in the start destination, the nav controller. And in here, we start building out the routes. It's a composable route. I like to add in the the named params, makes it cleaner. And here, so home is going to map to our home screen. And this is what I was talking about when we're passing in the navigation. So we're going to create a Lambda for on navigate to detail screen. So the home screen will be allowed to navigate to the detail screen, but the actual navigation will be handled here within the nav host file. And we're creating this Lambda, which is just going to call the nav controller, which we're passing into this nav host here. So we have access to it, and we're going to navigate to details. Now, we haven't created details yet. So no, also it's red because we also haven't created that Lambda yet within home screen. So let's come over to home screen real quick. Let's make this a composable, and composables are functions, not classes. And here, there we go, the on navigate to detail screen. This is where we're defining the Lambda. This is what we want it to actually do. Okay, so we're going to want to create a custom scaffold. We'll want to put that in like a core UI type module so that we can use that anywhere within the app and we don't have to change it every time. We don't have to implement a scaffold every time. I'll show you the part of the scaffold once we implement this. If you don't already know what a scaffold is, I'll just draw your attention to it real quick. All right, inside of the scaffold, we're going to want a column. Everything in Compose is rows and columns. It's super simple on that aspect. Let's give it padding of 16 dp, import dp. Okay, let's just go ahead and drop in a text that will navigate to the home screen. You can add a clickable to pretty much anything in Compose, and that just allows you to be able to click on the element. And then we just simply call or invoke that Lambda that we're passing in, the on navigate to details screen. We pass it in, or we go ahead and invoke it right here. Now you'll see that over here in our nav host, everything is happy. Let's go ahead and create the route for details. So as you see, details matches up with what we just said for nav controller.navigate to details is now going to come over and be able to handle to the composable. And in this case, we're just going to go to detail screen. Let's also make detail screen a composable. Again, it is a function, not a class. And let's just copy what we had from home screen to detail screen and change it to details. And there's no clicking in here, so let's remove the clickable. All right, we can import in detail screen and we are good to go. We can now implement the coding challenge nav host, and now we're really, really good to go. Let's add in what I just talked about with the core UI library. So we're going to create the scaffold. And this is just our custom wrapper to Google's Scaffold. That way we can have all the theming look exactly the same. In here, let's create a coding challenge scaffold. This is going to be composable as well. And let's not forget that the Gradle file also has to be updated to match. Let's bring it up to 33, and let's bring in all of the compose that we have, the compose elements that we have in app. Just copy, paste it right here. All right, copy in compose. Now we have the compose implementation. We go ahead and sync. And we also need to create the dependency on core UI, just like we did on networking. And now we'll see core UI has composables in here. We're going to change it to a function. Let's compose. And we're just going to build out a scaffold. We're going to want to pass in a title. That's what we're going to show up at the top bar. And we're going to have a content. Okay, now we implement the scaffold, which is Google's component, top bar, add this in, title equals, and we're passing in the title that we're passing in, that string, we're going to go ahead and drop it in here as this text, which is going to be the top text of the top bar. And we're going to go with material theme color scheme dot on primary. This is another great little talking point. One thing to note is never do a named color here, like a specific color. You want to use the themed colors. And material design gives you a certain set of like primary, on primary, tertiary, on tertiary, secondary, all of those sort of things. And in this case, what it is like primary is going to be the primary color. But if you're doing something on the primary color, it's going to be this other color. The reason you don't want to do something like green or black here is when you switch between dark mode and light mode, or even more than that. And this is another thing you can point out, even accessibility colors. So if you're switching between dark mode, light mode, accessibility colors, or any other sort of colors that a device might have built onto it, you don't want to have to program here with an if statement that says, well, if accessibility, or if this that we don't even know exists is what the case is, then go ahead and do blue. Instead, what's better is just go ahead and do what your built-in theming is, or that you're going to build in, because that's built into Compose to make it super simple for you. You can go ahead and define these. You can define your own names if you would like. I'll show you how to do that in another episode. Stay tuned for that one too. I'm going to show you guys a lot. I'm going to show you guys everything about Android, really. The importance here is this allows the user to be able to toggle and you to just define in one file all of these, bam. And then the app in Android is going to take care of all the rest magically for you. In the real world, you're going to have a design team that's going to tell you what these colors are. And a key thing, this is also a good point to talk about in interviews, because it shows that you've been in the industry long enough to recognize this, is there's always an issue with, well, I shouldn't say issue. There's always a little bit of tension between Android and iOS and the design team. Design teams usually design for iOS primarily, and so they will cater towards them. However, Android needs to be designed for as well. So one of the things I always try to get when I'm on a new team or a new company or a new position is I try to sit down with the design team and establish, or hopefully they've already got established, a color palette. And that's the palette we're going to stick to. So it might, you want only a few colors, maybe 8 colors total. And these all match up with the primaries, secondaries, tertiaries, those sort of colors. And you don't want to keep changing your color palette every 2 years when they hire on a new design team. So you want to drill in and get them to commit an agreement between the design team and the developers on the color palette and the naming conventions for that color palette. That way you can stick to something. When you look at the Figma docs or other docs, you can look at it and you don't have to just go with hex values and then try to see, oh, what does that match up with? Or is that in light mode? Or is that dark mode? Or is accessibility color? What color does that actually match up with? You get the design team, push that on them, on the design team to tell you, hey, well, you tell them that these are the naming convention we need. We need primary, secondary, and then you get them to fill it in and say primary in this case is this, primary in dark mode is this, primary in light mode is this, and then you can go ahead and map that up. Super simple. So by taking the point to mention that here when reviewing code, it shows whoever you're interviewing with, you've been in the industry a while, you already know some of the potential pain points, and also shows that you are proactive and it's something that you want to, that you can foresee pitfalls and you have a plan to address those before they ever happen. Those are brownie points. Okay, colors. Let's do the top bar defaults, minimum top bar colors, and let's set the container to a material theme. Again, we're going with material theme dot color scheme dot primary in this case. That way it's going to have a primary background, and on primary is going to be our text color. And we're dropping in the content. We're basically just dropping in the content and we're going to wrap in a column. Basically, all we're doing here in the content section, we're going to pass in the modifier. And this is the key thing right here on the modifier, the padding values.calculate top padding. I'm going to show you when we run this what that does. If you don't have this in here, then when you run it, everything in the content is going to be the full screen. So it's not going to account for that top bar that you just had, which is bad because the top bar covers a certain portion of the screen. So you want your content to start below that portion. So what this does is it goes ahead and adds does the padding, but it does the calculate of the top padding, which is the top bar padding. It calculates that and then just pushes down your content down that exact amount. So that's also going to take care of screen resolutions. So let's say that you have a screen with really high resolution versus a screen with really low resolution. If you were to just go in here and say padding 16, because the top bar on my specific device is 16, none of them going to be 16, but let's say 48. So the padding is 48, looks like 48 on my device. Then you go to a whole different resolution screen that's going to be offset. So again, right here, Google gave us a bone. You can just say calculate top padding. Voila. No matter what the screen resolution is, it's going to give you the right value. And it's just, again, just a wrapper for the content we're passing in. So drop in content, padding values. This is good to go. And we had to add in the experimental. We had to add in experimental material 3 API. We are using some experimentals with this. I imagine they're probably going to be stable by the time you're watching this, if not outdated already, because everything in the industry goes so fast. It's insane, which is why I don't feel bad using an experimental API for a coding challenge. And you'll actually find that in the industry right now, there's a lot of experimental APIs being used in the wild. All right, so we can go back and we can replace our to-do of a coding challenge scaffold or to-do of the scaffold with our actual implementation of a coding challenge scaffold. Simple one-liner wrapper. It takes care of this for us. Let's also do the details screen, and let's change the word home to details. And when we run this, okay, so we can see here and now see that scaffold, how the scaffold is this certain padding height. Because we added in that calculate top padding, we push on the home screen component based off of what our padding actually was. This matches up. If we didn't have that there, the home screen words on the home screen component would actually be hidden behind the home. And because we have the clickable added in there, when we click, we can see it actually navigates to our details screen. How exciting. We're almost there, guys. Almost there.